I'm in the thick of it, everybody knows. They know me where it snows, I see it in and they froze. I do not know nothing about no ice, I'm just cold.
Alright, so how to solve three variable system of linear equations. So we're going to be solving this by elimination, and here are just two examples of elimination in case I don't know what that is. What I can do is, you'll notice how we have a 2x on the top and a 2x on the bottom. So what I can do is I can add up these two equations together. 2x plus negative 2x is just going to be 0x. Negative 4y plus 3y is just negative y, and 5 plus 8 is just going to be equal to 13. So you notice elimination is useful because you literally just eliminate one of the variables from the equation, right, from these two equations, and it makes it much easier to solve. You can also do it in, let's say, if you have, let's say, 2x minus 4y is equal to 5, and let's say 2x plus 3y is equal to 10. Well, in this case, you have a 2x on the top, you have 2x on the bottom, so I can subtract these two equations. So now, instead of adding these two equations, I can also subtract these two equations. Because now, in this case, 2x minus 2x is just 0x. Negative 4y minus 3y is negative 7y. And 5 minus 10 is equal to negative 5. So in order to solve this, let's say if I want to pick a random variable to eliminate. For this problem, I could pick any variable. I can eliminate y first, or I can eliminate z. But in this case, I'll just eliminate x. And what you want to do is basically, this is the first equation, this is the second equation, this is the third equation, and what I'm trying to do right now is I'm trying to eliminate an x from the first and second equation. So how do I do this? How do I get rid of the x from the first and second equation? Well, if I want to get rid of x, I'll just subtract these two equations. X minus x is just 0x. Negative 2y minus negative y, you'll notice negative makes a positive. So it's the same thing as negative 2y plus y, which is equal to negative y. Negative z minus 3z is just negative 4z. And 4 minus 0 is equal to 4. Alright, so first step is done. Now, the second step is to eliminate an x from the first equation and the third equation now. So how can I eliminate an x from the first equation and the third equation? Well, another good thing about systems of linear equations is that you can multiply these equations by any quantity as long as you multiply both sides by it. So what I mean by that is, let's multiply this equation by 2. All right, so I multiply everything in this equation by 2. So 2 times x is 2x. 2 times negative 2y is just going to be negative 4y. 2 times negative z is negative 2z. 2 times 4 is just going to be 8. And now you'll notice how we have 2x on the top and 2x on the bottom. So we can subtract these two equations. 2x minus 2x is just 0x. Y minus negative 4y is 5y. And z minus negative 2z is positive 3z. Right? Negative makes positive. 0 minus 8 is just going to be equal to negative 8. And now what you notice is that we have now a two variable system of linear equations that we can solve, which makes this process a lot simpler. So once again, how can we solve this? We can use substitution to solve this. But once again, for the sake of this video, I'm going to be using elimination because that's what we've been doing the whole time. So in order to get rid of, in this case, it looks like the y's are pretty good to get rid of. They're pretty easy to get rid of. All I have to do is multiply the bottom equation by 5. So when I multiply the bottom equation by 5, I get 5y plus 3z equals negative 8. And then now I have 5 times negative y, which is negative 5y. 5 times negative 4z is negative 20z. And 5 times 4 is 20. Now you'll notice we have a 5y on the top equation and then a negative 5y on the bottom equation. So in order to get rid of these two variables, I could just add the two equations together. 5y plus negative 5y is just 0y. 3z plus negative 20z is negative 17z. And negative 8 plus 20 is just going to be equal to 12. If I divide both sides by negative 17, I get that z is equal to negative 12 over 17. Now that we know what z is equal to, we can substitute z back into one of these equations, one of these mini system of linear equations, and we can solve for y. because it's two variables. So in this case, let's substitute it into the second equation. So we have negative y minus 4 times negative 12 over 7 equals 4. Negative 4 times negative 12 over 7 is negative negative makes positive, so it's just going to be negative y plus, and then 4 times 12 is 48 over 17 equals 4. 48 over 17, that's just going to be 2/14 over 7th. Negative y plus 2/14 over 7th equals 4. These are some annoying fractions. I can rewrite 4 as 2/34 over 17th. And if I subtract both sides by this quantity, I'm just going to get 20 over 17. Negative y equals 20 over 17. It is just, sorry, this is like annoying fractions. But yeah, if you subtract both sides by negative, so you subtract both sides by negative 2/14 over 17th, this cancels out, and 2/34 over 17th minus 2/14 over 17th, well, these 2's cancel out, and 34th over 17th minus 14 over 17th is just 20 over 17th, which is what I have on the top. And to solve for y, just divide everything by negative 1, right? Because negative negative makes positive, so I get y is equal to negative 20 over 17th. Now that we know what z is equal to and what y is equal to, well, we can substitute both of these variables back into one of the bigger equations. So let's just substitute it into the third equation, because sometimes you just gotta, when doing system of linear equations, you just gotta ask yourself, kind of, what's the simplest equation I can substitute everything back into? In this case, right, if I substitute it back into, let's say, the first equation, I have to multiply 2 times whatever y is, and I get really annoying fractions. But in this case, inside the third equation, I don't really have to do any multiplying. So that's pretty nice. So I get 2x plus y. We know that 2x plus y, that's 20 over 17th, right? 2x plus 20 over negative 20 over 17 plus z, so plus negative 12 over 17 plus negative 12 over 17th equals to 0. If we simplify these two values, we get 2x minus 32 over 17th equals 0, right? Because negative 20 minus 12 is negative 32nd, and we can just add 32nd over 17th to both sides. And now to solve for x, we can just divide both sides by 2. So we get that x is equal to 16th over 17th. And that's going to be our answer. And now let's use the same strategy for this problem. So if this is our first equation, this is our second equation, this is our third equation, how can I make the first equation, how can I eliminate a variable from the first equation and the second equation? And let's just say the variable I'm eliminating is x, once again. And the reason why I'm eliminating x is it's actually, well, if you kind of visualize this, okay, if I want the second equation, if I want to eliminate an x from the second equation and the first equation, all I got to do is multiply the second equation by 2, so that this 2x matches up with this 2x. And I could just subtract the top and the bottom equations. And if I want to eliminate the x from the first equation and the third equation, well, all I have to do is multiply the top equation by 2, so that I get 4x, and 4x plus negative 4x gives us 0x, so the x is eliminated there. So you'll notice how to plan for this problem is pretty simple. So in this case, I'm just going to multiply the second equation by 2, so I get 2x plus 4y minus 2z is equal to 8. Now that I have the top and bottom equations lined up, let's do some elimination. These two x's cancel out. 4y minus negative y is just going to be 5y, right? Negative negative makes positive. Negative 2z minus 3z is negative 5z. 8 minus 2 is equal to 6. Now let's try to eliminate an x from the first equation to the third equation. So I already told you the plan. I already told you how to plan. Multiply the first equation by 2. So I end up with 4x minus 2y plus 6z is equal to 4. And now I'll just bring the third equation here. So now you'll notice how we have a 4x and we have a negative 4x. So these cancel out, right? If we add these two equations together, this 4x, this negative 4x cancels out. 2y plus 5y is 3y. 6z plus z is just going to be 7z. 4 plus 10 is 14. And now, once again, we end up with a two-variable system of linear equation. So now that I have this two-variable system of linear equations, how can I solve this? Well, I want to do elimination once again. So in this case, I'm going to multiply the top equation by 5. I'm going to multiply the bottom equation by 3. So what I'm going to do now is I'm going to multiply the top equation by 5. So I get 15y plus 35z is equal to 70. I'm going to multiply the bottom equation by 3. So I get 15y minus 15z is equal to 18. The reason I did this is because, well, 15 is the lowest common multiple of 3 and 5. So in this case, now we have two 15y's. They're matching. And now we could just subtract. 15y minus 15y is just 0. 35z minus negative 15z is just going to be 50z. 70 minus 18 is just going to be equal to, 52. So z is going to be equal to 52 over 50. Let's simplify this a bit. This is 26 over 25. Now that we know what z is equal to, let's substitute it back into one of the mini system of linear equations. So in this case, let's just say I substitute it into the first equation. I get 3y plus 7 times 26 over 25 equals 14. 7 times 26 is just 182, and then this is over 25. And then 182 over 25. We can also rewrite 14. We can also rewrite 14 as 350 over 20. Subtract 182 over 25 from both sides. So once we subtract that, we get 168 over 25. Multiply both sides by 25. We have 75y is equal to 168. Divide both sides by 75. We get y is equal to 168 over 75. We can also simplify this to, if I divide 168 by 3, I get 56. So this is equal to 56 over 25. Let's substitute it back into one of the equations. Let's just say we substitute it back into the second equation. So we have x plus 2y. So we know 2 times 56 over 25. And then this is going to be minus z, so minus 26 over 25 is equal to 4. 2 times 56 is just going to be 112 over 25 minus 26 over 25. And then you can simplify this into 86 over 25. It's just going to be 86 over 25. X plus 86 over 25 equals 4. We can rewrite 4 as 100 over 25. So subtracting both sides by 86 over 25, we get x is equal to 14 over 25. And there's our answer.